Hi folks, we're going to take a look at number 15 from page 111 from the Unit 1 assignment. So they give us this function, which is not a function we're used to working with. So they also give us the graph. So this is what this function here looks like. And they want us to determine the slope of the tangent where f crosses the x-axis. So in other words, at this point here, looks like there's two x-intercepts, but we're looking for where it crosses the x-axis. And then they want us to find this value a. And what's special about this value a, where it looks like the slope of the tangent is equal to 0. All right, so let's start with the first one. So we're going to find the x-intercepts. Presumably one should be 0, and then whatever the other x-intercept will be the one we're looking for. So let's let y equal to 0. So here we've got 2x to the 5/3 minus 5x to the 2/3. All right, and here what we're going to use is a little trick, which you're well aware of. We're just not used to using it in this context, and we're actually going to do some factoring here. But because our exponents are not natural numbers, doesn't look like the type of factoring that we normally do. We normally look for how many x's are in common in both of these expressions. Can't really look at it this way. So what I'm going to do is I'm just going to divide out, I'm going to factor out the lower, whatever the lowest power of x is, which in this case here is x to the 2/3, and I think we're going to see something nice is going to happen. So if I factor out x to the 2/3, okay, so I know in that second expression I'm just going to be left with 5, all right, because this whole thing is being factored out, and I think we're going to see something nice is going to happen in the first expression. So I still have the 2. So when I factor something out, I'm dividing it from both of the expressions. So when I divide x to the 5/3 by x to the 2/3, well, I simplify that by just subtracting the exponents. And 5/3 minus 2/3 is 3/3. So I'm just left with x. And so now I've got something much nicer to work with. So what makes this 0? Well, if x is 0, okay, not the x-intercept we're looking for, because we knew that one already, but it's not crossing the x-axis, or we have x is equal to 5/2, so that must mean that's the other one, which is the one we want to work with. All right, so now we know the x value at which we're working at. It's just a matter of determining the derivative there at that point. So let's now find the derivative of this function. So f prime at x is equal to, so we just apply a derivative property, so that's just a constant, 2. And now let's find the derivative of x to the 5/3. Well, it's just going to be 5/3 times x. Well, 5/3 minus 3/3 is 2/3. Okay, and then minus 5, again just a constant, and let's find the derivative of x to the 2/3. So again, it's just 2/3 times, 2/3 times x, and 2/3 minus 1 is negative 1/3. All right, so if we just simplify that a little, we've got 10/3 x to the 2/3 minus another 10/3 times x to the negative 1/3. All right, this is not exactly a nice function again to work with if I need to input my value of 5/2, because I'm going to be stuck with some pretty ugly expressions to work with. So I'm going to do the same thing as I did before. I'm going to see if I can do some factoring to write this in another way. All right, so I'm going to factor out the 10/3 for sure. That's common to both. And again, I'm going to factor out the lower of the two exponents, which in this case here is negative 1/3. So let's factor out an x to the negative 1/3. And what are we left with? So we factored out this whole expression on the right, so I'm just going to be left with minus 1. Let's see what happens here. I factored out the 10/3. 2/3 minus negative 1/3 is the same as 2/3 plus 1/3. So hey, again, I'm just left with x, and then here, minus 1. And this is much nicer to work with, and in fact, I think it's going to help me with part B. All right, but let's finish part A. So what we want to do is we want to find the derivative at 5/2. And this is where we're just going to have to work with our exponent rules to simplify this, I think. All right, so we have 10/3. Okay, so we have 5 halves to the negative 1/3. Okay, we may have to work a little with that later on, but what do I have now? I have 5 over 2 minus 1, so 5 over 2 minus 2 over 2 is 3 over 2. All right, so a couple of nice things happen. This 3 here reduces with that 3 there, and this 3 here, this 5 there reduces with the 2, so I'm left with a 5. And let's see what we have left. All right, so I have this 5. Now remember that a negative exponent just gives me the reciprocal. Okay, and of course, I still have this exponent, which I'm going to apply to both numerator and denominator. Okay, so because of the negative exponent, the 2 comes to the numerator, so I'm going to be left with 2 to the 1/3. And then I'm going to have in the denominator my 5 to the 1/3. All right, but here I can do a little bit of simplifying. Okay, this is 5 to the 1 divided by 5 to the 1/3, so 1 minus the third is 2/3. So 5 to the 2/3 times 2 to the 1/3. All right, and hey, 1/3, that's just a cube root. So I'm going to write this as 5 squared cube root, and this is the cube root of 2. So now I can bring these two together because I'm multiplying two similar roots. They're both cube roots. So I'm just going to end up with the cube root of 25 times 2, which is 50. And there you have it. There's the derivative of f at 5 over 2. So let's just recap A before we go to B. So the first thing we did was, in order to find the x-intercept, I did some factoring, okay? But we see that factoring is also useful even when our exponents are not positive integers. You just factor out the lowest power of x. Then when we took the derivative, we did the same thing to simplify our derivative formula. We factored out the lowest power of x, and then when we inputted 5 over 2, it was essentially just an exercise in using our exponent rules. Okay, so let's go to B. So for B, we know that at A, the derivative should be 0. So I'm just going to take the derivative and equate it to 0. But I'm going to use this version of the derivative because it's already factored. So I'm just going to equate that to 0. So 0 is equal to 10/3. Okay, and here I'll bring this negative into the denominator. So cube root of x is in the denominator. And the reason why I did that is just to make sure that it's clear that x being 0 is not acceptable here because it's in the denominator. So the only thing that makes this expression 0 is if x minus 1 is equal to 0. In other words, if x is equal to 1. And there's our A value. All right, so just to recap B, is I took my simplest form of the derivative, the one that was factored, equated it to 0, and we saw that there was only one x value that makes this derivative equal to 0. Hence, that must be my A value. Okay, which makes sense because this was 0. We already found out that this was equal to 5 over 2. So A equals 1 is an answer that does make sense. Okay, that's it for this one.